You may believe you have a perfect body, excellent health, but then a sudden sharp pain in your lower jaw nearly makes you faint. This is the culprit. And then you begin to wonder, why does this useless thing exist in our body and even endanger us? But it is not just the story of a single tooth. It raises the issue, are these flaws accidental? Or are they the price we pay in the process of evolution? Perhaps you don't need to worry too much about your imperfections. Because in nature, other organisms also carry unusual traits. In the tropical forests of Madagascar, there is a strange orchid. Its nectar tube is longer than any flower ever known before. In the 19th century, naturalist Alfred Russel Wallace received a pressed sample of this orchid. Immediately he thought, there must be some insect with a proboscis equally long, or even longer, to suck the nectar and pollinate the plant. Wallace named this creature the Death's Head moth, inspired by the Sphinx moth group. In 1903, the mysterious creature officially appeared. It was later confirmed as a distinct species based on genetic analysis in 2021. The name Death's Head was also changed to Wallace's moth, to honor the man who predicted its existence. To this day, it remains the insect with the longest proboscis ever discovered. That unusually long proboscis allows it to survive in its special environment, where orchid nectaries can reach 30 centimeters in length. But is Wallace's moth truly a rare case in nature? In the dark depths of the ocean, another creature will surprise you even more. The anglerfish. Famous for its glowing lure protruding from its head. Its jaw can expand up to 90 degrees. But that's not all. When anglerfish were first discovered, researchers were shocked. Every specimen was female. Some even carried tiny organisms clinging tightly to their bellies. Even more surprising, they found those organisms were actually male anglerfish. Indeed, in anglerfish, nature has created a unique mechanism. Females grow into fierce predators. Males, however, are only about 6.35 millimeters long, 1/500 the size of the female. They cannot live independently. A male must permanently attach itself to a mate to survive and reproduce. Over time, its body wastes away, leaving only the testes to fertilize the female in cycles. Compared with anglerfish or Wallace's moth, our own evolution seems fairly ordinary. Yet there are exceptions. Have you ever looked deeply into someone's eyes? The white sclera of the human eye is an extremely rare feature in the animal world. In most species, this part is dark, matching the iris color, or hidden completely behind the eyelids. In contrast, the human eye displays a bright white sclera, making it easy to see where others are looking. This is a clear evolutionary advantage, especially for a social species like you and me. The eye acts as a tool for communication, sharing thoughts and building trust in communities. You know whether someone is trustworthy from their eyes, whether they are sad or happy. Also from their eyes. However, not all differences are so useful. Some even become hidden threats to our health and relationships. Take the appendix. It is a small tube attached to the colon. You inherited this from herbivorous ancestors millions of years ago. Initially, it was thought the appendix stored beneficial gut bacteria. But in reality, it has no function today. Worse, it can easily become inflamed or burst, posing serious risks. Surely you've heard of someone who had their appendix removed and still lived healthily. So the question is, why has such a dangerous organ survived through millions of years? Back in the 19th century, when Wallace predicted the moth in Madagascar, the scientific world erupted into fierce debate. The central topic was Darwin's theory of evolution. His book on the origin of species claimed that all organisms evolved through natural selection. The world is an endless competition where all struggle for food and mates. Those with superior traits survive, reproduce, and pass down advantages to offspring. This process continues endlessly, spreading beneficial traits in populations. Small adjustments lead to new species-level features. To see it more clearly, look at dogs. Perhaps even the very dog you own today. About 15,000 years ago, Some wolves began approaching humans, feeding on leftovers near settlements. Among them were your ancestors' companions. They grew less fearful, moving freely among human communities. Over hundreds of generations, people selected and bred wolves that were gentle, obedient, and loyal. One of those wolves was the ancestor of your dog. Thus, from wild wolves through natural selection, domestic dogs were born. The most controversial part of Darwin's theory was one of its core principles: gradual change. At the time, many still believed life developed toward predetermined goals, such as the eventual rise of human intelligence, or under divine guidance. But Darwin called for abandoning the idea of some grand design for evolution. He argued that everything, including us, is the result of purposeless natural selection. Opponents like Carl Ernst von Baer argued that blind, undirected forces could never create order. Imagine building a house. If bricks, cement, sand, and steel simply fell randomly, without planning or design, then even after 1,000 years, that pile would never become a house. Von Baer believed life was the same. Human eyes, bird wings, hearts, and brains are as complex as designed works, and thus could not arise from blind change. So there must be some guiding principle or hand. By contrast, naturalist Thomas Henry Huxley supported natural selection. Yet even he initially felt small gradual changes were too trivial to explain the richness of life. If all originated from one common ancestor, and only shifted slightly each generation, it would take billions of years to yield today's diversity. Other scholars suggested species did not change gradually, but underwent sudden large transformations in stages. They pointed to the lack of transitional fossils as evidence. But this problem was soon addressed. In the late 19th century, Archaeopteryx was found in Germany. This fossil clearly bore dinosaur traits, yet also bird features, feathers and wing structures. Archaeopteryx provided the first evidence of the link between reptiles and birds, revealing gradual transformation in life. Thus, Darwin's concept of natural selection was further confirmed. Feathers in Archaeopteryx may not have evolved for flight at first, but for insulation or courtship display. Over time they were repurposed for flying, gradually creating a flying creature. Yet evolution not only produces new structures, it also leaves behind remnants once useful, now useless or harmful. Your body shows this vividly. In early times we had to chew raw, tough foods requiring powerful jaws. But today food is chopped and cooked, making chewing easier. As a result, modern human jaws have shrunk, leaving no space for all 32 teeth. Wisdom teeth, erupting last, often grow crooked, impacted, or press into neighbors. They can cause severe pain, infection, or nerve damage, even when properly aligned. Their deep position makes them hard to clean, leading to decay or gum disease. You yourself may have suffered from these useless teeth. This shows evolution is not about perfection, but a story of compromises between benefits and costs. Almost every advantage carries a price. The peacock's brilliant tail attracts mates, but makes it easier to be hunted. In the past, saber-toothed cats had huge fangs 28 centimeters long, with muscular bodies and fearsome jaws, dominating the Ice Age food chain. Yet their bite force was weaker than modern big cats, only a third that of lions. Their lower jaw structure had to narrow to fit oversized fangs, which also broke easily in violent struggles, removing their main weapon. Such individuals often starve to death. Humans too reveal many trade-offs. Under the burning sun, your skin burns without thick fur like ancestors had. Thus we need clothing and sunscreen. In cold weather, our bodies quickly lose heat, risking hypothermia. Even spending much time indoors brings other problems. Sedentary habits weaken muscles and reduce fitness. Lack of sunlight lowers vitamin D, vital for bones and immunity. Yet, having little body hair also helps humans cool effectively through sweating. Not all biological traits exist due to trade-offs. Some persist purely by chance. This process is called genetic drift, an evolutionary mechanism driven by randomness. Imagine a bag of red and blue marbles. You grab a handful without looking. The proportions may be 50 to 50, 70 to 30, or any ratio. If this happens in a population, a catastrophe might wipe out most individuals. Among survivors, the balance of traits resets randomly. Sometimes harmful traits become more common than beneficial ones. This is the bottleneck effect, making rare, even harmful traits spread. Another example is the founder effect. A small group splits off, bringing only a limited set of genes. Perhaps 10,000 years ago, only a few carried the blue eye mutation. If they migrated and founded a new group, that trait became common in the new population. Today you may inherit those blue eyes. Science still debates whether blue eyes are advantageous. Some suggest better vision in low light. Others note disadvantages, like sensitivity to bright light and higher risk of UV damage to the cornea. Among all our differences, walking upright on two legs may be the biggest, riskiest trade-off. Bipedalism frees our hands for delicate tasks, but reduces agility for climbing like other primates. Standing fully upright is rare in animals, seen in only some birds and kangaroos. Even then, their anatomy differs. Theropod dinosaurs, ancestors of birds, balanced with tails. Most birds walk on toes, not flat feet, helping them run faster. By contrast, humans walk on whole feet, offering stability and endurance for long distances, but less speed and reflex agility. Kangaroos, though standing on full feet, hop by springing on toes. Bipedalism also relates to losing our tails. You can still feel its remnant in your coccyx. In 2024, a surprising hypothesis emerged. When primates first began to stand on two legs to forage, the tail, once essential for balance, gradually became unnecessary. Around 25 million years ago, when primates stood upright to forage, tails became less useful and disappeared. Research suggests a rare jumping gene mutation moved within the genome, disabling tail development. Experiments replicating this mutation in mice produced tailless offspring, but also increased spina bifida risk. Furthermore, standing upright forces our spines to bear vertical compression, though we evolved from quadrupedal ancestors. Thus humans suffer common spine problems: lower back pain, herniated discs, degeneration. The greatest trade-off falls on women. Bipedalism narrowed the pelvis. Yet human babies have large heads. This mismatch makes childbirth painful and dangerous. Unlike most mammals who give birth easily, clearly the cost of evolution's advantages is high. Yet humans possess one gift most creatures lack: the ability to adapt with intelligence. Our bare skin? No matter, we invented clothing and sunscreen. Leaving Africa, ancestors faced cold climates. They used furs, plant fibers, bird feathers to insulate against the chill. Caves once used as shelters from predators became refuges from freezing cold. Eventually humans built houses and tailored clothes to protect against harsh weather. Observing the human body, you see a complex structure shaped by countless evolutionary traits. Many organs are mere vestiges without clear function, sometimes harmful. Others are results of trade-offs, new features arriving with costs elsewhere. Yet thanks to creativity and knowledge, humans devised solutions to overcome biological limits. This shows that our evolutionary journey is not only unique but also proactive. And in the future, what kind of creature will we become?